In this video, we're going to talk about how to name hydrocarbons containing functional groups aldehydes and ketones. And we're going to talk about this together because they both contain carbonyls, which is a carbon double bonded to an oxygen. The only difference is in a ketone, that group is between two other carbons, so it's part of the chain, and in an aldehyde, it is at the end of the chain. At least one of those ends is attached to just a hydrogen. Let's name aldehydes first because they're easier. We don't have to tell the location of this carbon and this double bond because it's always at the end. By definition, if it's an aldehyde, it's at the end. So we don't have to use numbers for this. We just we drop the E at the end and make it Al. So this example here, let's draw one real quick. And we'll show it in our condensed form. So you can get used to seeing it like this. Aldehydes will end with CHO. We can draw this out if you choose to. And we see 5 carbons, so it would be pentane. And because it's an aldehyde, it would be pentanol. Al. Now, if there was a double bond in here, it would just be pentene, and then you'd have to tell where that double bond in between the carbons was. Here's a second example. The way that these get more complicated is by adding branches. So in our condensed format, we have this. We can pull it back out. We know that this is not 2 more in the train for 2 reasons. That's a 3, which means they have to be methyl. It has to be out by itself. And because this carbon needs these 2 extra bonds on it. If this oxygen was not here, this would be carbon number 1 because it would be closest to the branches. But in an aldehyde, the carbon attached to the oxygen is always number 1. So we have 4, which is butane. We have 2 methyl groups. So we would say 3,3-dimethyl butanal. And the Al here tells us that it's an aldehyde. And this tells us that there are 2 methyl groups on the 3rd carbon away from the aldehyde. One more example. In this example, you can see that we actually have 2 different functional groups. We have a halide here, and we have our aldehyde. So we can draw this out. 4. We have chlorine there. And we have our aldehyde here. Remember, this is always 1. So 1, 2, 3, 4, 5. So it's pentane. The chlorine is on the 2nd one, so using our halohydrocarbon rules, we would say 2-chloro, and then using the name of our hydrocarbon chain is pentane, and then we would drop that final E and add Al to tell us there's an aldehyde. So naming aldehydes is one of the easier functional groups, I think, because all you do is take off that E and add Al, and it tells you exactly which carbon has to be number 1. It has to be the one in the aldehyde. Let's look at those ketones. Ketones are not quite as simple because that double bonded oxygen is in the middle. The condensed format looks like this. You can find the carbonyl group right here, where we have CO. You know it has to be double bonded because this carbon needs 4 bonds. One's this way, one's this way. The other 2 must be with the oxygen. And because oxygen's often double bond with carbons and hydrocarbon chains when it's not an alcohol. So if it's not an OH, there's probably going to be a double bond. We can expand it. 2, 3, 4. So a nice simple one. You're going to number your carbons so that the ketone functional group has the lowest number possible. 1, 2, 3, 4, 5, 6, 7, 8. And because in this case, the ketone does not have to be on the end. In fact, it cannot be on the end. You have to tell where it's located. So 4, this is an 8 carbon chain, so it's octane. We drop that final E and add O-N-E. So this is 4-octanone. The 4 tells us that's where the functional group is. Octa tells us that there are 8 carbons in a chain, and O-N-E tells us that it's a ketone at 4. So all parts of this name do something to help us know what we're talking about. So I worked with these with my husband, who's a chemist, and he kind of laughed when I told him the name of this was 4-octanone. And he said, yes, that's the IUPAC name. But in a lab, at least in the US, scientists very rarely use the IUPAC name for ketones. Instead, for a ketone, what they'll typically do is treat this like the main part and treat these like the functional groups. So it's 3 here. So you would say propyl. There are 4 carbons on this side, so that would be butyl and a ketone in the middle. So the common name for this is propyl butyl ketone. And it doesn't matter which one you say first. You can say butyl propyl ketone. Either one is fine. For ketones, I will accept the IUPAC or the common name for it. You don't have to learn both. It's pretty easy because I think the common name makes sense. Ketone in the center, a propyl, and a butyl group. But either way, I would accept that answer. Let's look at another example. This is the most basic ketone we can have. And using IUPAC naming, you would say, this is on the second carbon, so you would say 2, this is 3 carbons, so it would be propane. So we would say propanone. This would be 2-propanone. Using the common name, you would say there's a methyl on each side, so it would be dimethyl, because there's 2, ketone. Again, you can use either name. I just want to show you both conventions because I don't want you to be out there in a real lab setting and not know what people are talking about. And I just want you to be aware that there are 2 conventions. IUPAC is the official, and a chemist would recognize what that means. 2-propanone means this. But in a lab, they would say dimethyl ketone. It's just like the IUPAC name for water is dihydrogen monoxide, but we never call it that. We say water. So sometimes the common names get used far more, particularly with ketones, because I feel like that naming convention is a little easier and it doesn't involve numbers, which makes it kind of look a little cleaner. Let's do another example, one more. So in this example, we have another branch off of our chain. When we expand it, we see that there's a methyl group there. Using IUPAC naming, we would number it this way: 1, 2, 3, 4. We would say 3-methyl, because that's where our methyl group is. 2, it's a chain of 4, so it'd be butane. And we would change that to butanone. So we would say 3-methyl 2-butanone. Once we get outside of the real simple ketones, often we refer back to the IUPAC naming instead of the common naming, but this one we can use the common naming for as well. Here's our ketone. We have a methyl here. And with the common naming, we don't really have a way to deal with branches off of one of these side chains, so it works best if they're straight lines, except for this particular situation. Because if you look at this as one chain, 1, 2, 3, that's propane. And we've talked about propyl. When you connect in the middle, we say isopropyl. So this ketone has a methyl group on one side and an isopropyl group on the other side. So we would say methyl isopropyl ketone. Now, if this got more complicated, even one more carbon, don't try to do common naming for it. Go with just the IUPAC naming.